Hello and welcome to section 5 of the next installment of the geometry videos. And this is a section about trapezoids and kites. Okay, so our objectives today, we want to complete proofs involving properties of trapezoids and kites. We want to apply properties of trapezoids to solve mathematical and real-world problems and do the same thing for kites. Okay, so the first thing I want to talk about is this little guy up here. And feel free to use this QR code to see what happens, but all I know is this is a character, General Akbar, I believe, from Star Wars, and he is famous for having the phrase, "It's a trap! It's a trap!" But I like to think of this section as, "It's a trapezoid." Pretty good, huh? Okay, yeah. All right, so let's talk about what a trapezoid is. So we have a quadrilateral, so it is a four-sided figure, but we have one set of opposite sides that are parallel, and that's it, okay? So we just know that these two are parallel and these two parts are not, all right? And so we have some different types of trapezoids. So we also talk about, let's talk about this, that these are the bases. We call this the base, and this is the base, okay? And then these are legs, okay? And so we have two different types of trapezoids. And if the legs are congruent, and that's the question we ask ourselves, is do we have a trapezoid, okay? Or we have a trapezoid. And we ask the question, are the legs congruent? If we answer yes, then we have an isosceles trapezoid. If the legs are not congruent, then we have a scalene or right trapezoid. So this one would not be, we don't have any indication that these legs are congruent, okay? But let's go ahead and talk about the different types. So we have isosceles trapezoids. Now, what we have is, we know that two sides are parallel, okay? And FG is not congruent to EH, okay? But we know that these FE and GH are congruent, so we call this an isosceles trapezoid. Okay, if we have a right trapezoid, that means that we have two right angles, okay, and WZ and XY are not congruent, okay? Same thing with the scalene trapezoid, all right? A and B are not congruent, but we have two pairs of parallel sides, okay? So then, all right, we have the angles of a trapezoid. So if a trapezoid is isosceles, then its base angles are congruent. And so what I could come in here and say and label is that angle B is congruent to angle C. All right, I'm going to write that up here. That angle B is congruent to angle C. Now, we also know that angle A would be congruent to angle D. Okay, so I'm going to write that angle A is congruent to angle D. All right, and that's only if you've got a quadrilateral with parallel sides and these two legs are congruent. Now, the other thing that's pretty cool is that if I were to take angle A and add it to angle B, okay, angle A plus angle B, if I add those together, these are supplementary, all right? So I'm going to come in here and label that here, that we have supplementary angles, okay? These are supplementary angles. All right, and the same thing with C and D. Okay, these are also, and I'm going to come in here and write that here, that these are supplementary angles. All right, and so if they are supplementary, I can take angle A and angle B, add it together to get 180 degrees, and I can take angle C and add it to angle D and also get 180 degrees, all right? And so that's what I know. So an isosceles triangle, then, we can just go ahead and make all of these claims, that these angles are congruent, so are these, and that consecutive angles here and here are supplementary, okay? All right, so now what we can conclude is, let's say you have a picture and you say that if a trapezoid has one pair of congruent base angles, then it is isosceles. So if you say that E is congruent to H, then we know that FE is congruent to GH, all right, provided that we know that these two sides are parallel. All right, same thing with angle F and angle G. If we have this pair of congruent angles, then you can automatically conclude that angle E is congruent to angle H and all that. So, okay. All right, that's all I have for this page. Let's see what we got for the next one. Okay, on this next one, let's take a look at an application problem, and it says, the problem is the city planners want to design a park between parallel streets, Main Street and Willow Lane. So we know that Main Street and Willow Lane run side by side and they're parallel, okay? And they make a shape of a trapezoid, okay? There are two paths of equal length on the east and west side of the park. So we have our east path and we have our west path. And what we notice about those is that those lengths are congruent, okay? And we know that the border of the park makes a 60-degree angle between Willow Lane and the east path. Now, what I know is that, and I'm just going to label this triangle, all right? I know that these two legs are congruent, okay? So therefore, I can conclude that this angle and this angle are congruent, and then I can conclude that these two angles are congruent. So without doing anything, I automatically know that this is going to be a 60-degree angle, okay? Now I need to figure out what this is. Now what I know, I'm just going to call this x, okay? And so I would set up an equation and say x plus 60 degrees is equal to 180. And if I subtract 60 from both sides, then I get that x is equal to 120 degrees. So I know that this angle here is 120 degrees, and so is this one. This is 120 degrees as well, all right? And so automatically, just by looking at this, knowing the properties, knowing that these are congruent, and these consecutive angles here are supplementary, we can just automatically do that. So then it says, okay, we can answer the question. What is the angle between Main Street and the west path? And we already did that. We know it's 120 degrees, okay? And then it says, what is the angle between the west path and Willow Lane? Okay, so here's the west path and here's Willow Lane. We know that that's going to be 60 degrees. So not too terrible, just, being able to solve these types of problems, knowing what these are, okay? All right, the diagonals of an isosceles triangle. Now, if you have an isosceles triangle, knowing that BA is congruent to CD, okay, we also know that the diagonals are congruent. Okay, so I can say that BD is congruent to AC. So I'm going to say that here, that BD is congruent to AC. So that, big thing about this, guys, is just understanding, being able to read this and being able to label that on the picture and draw some conclusions and know what's congruent to what, okay? All right, the next one, let's talk about properties of kites. Okay, so a property of a kite, a quadrilateral in which two pairs of adjacent sides are congruent and opposite sides are not congruent is called a kite. Okay, now with a kite, I've got a few things. So I know that WZ is congruent to WX, okay? And then XY would be congruent to YZ, okay? I know that, all right? I also know that my diagonals, all right, my diagonals are perpendicular. Okay, so what I would do is I could also come in here and say that WY, if I connect those two and then connect XZ, I know that we form a right angle here. Okay, so I would say this, that WY, that segment, is perpendicular to XZ. All right, now I also know that the this diagonal here, WY, also is an angle bisector. So I can cut these two angles in half, or that angle in half, and then I can cut this angle in half as well. Okay, so kind of interesting. You get some interesting congruent triangles inside of here, and just something else that we know. Oh, also, I know that, and let's make this point O here, the intersection of those two. I also know that XO is congruent to OZ, all right? So anytime that we have that, so let's kind of put that into perspective here. The diagonals are perpendicular, and the long diagonal, okay, the long diagonal is an angle bisector, so angle bisector, okay, and it's also a perpendicular bisector to the other diagonal, okay? So, that's all the stuff that we know about kites, okay? So then, okay, let's kind of look at another problem here, okay? It says, Kara is building a sandbox shaped like a kite for her nephew. Isn't that nice? It's a nice thing to do for your nephew. Okay, the top two sides of the sandbox are 29 inches long. So I've got these two sides are 29, okay? The diagonal DB has a length of 40 inches. So the whole thing is 40 inches. I'm going to come in here and label that. This whole thing is 40 inches. Okay, now if that thing is cut in half, all right, I'm going to create another point here. I'll call this point O. That each of these lengths would then be 20 inches and 20 inches, all right? And I also know that if it is a kite, then these angles form a right angle. Okay, so we can actually, we actually have right angles in here, and we can use the Pythagorean theorem to figure out what this length is and what this length is, respectively. Okay, so then it says, what is the length? Okay, it wants to know what is the length of the diagonal AC. Okay, and so like I said in there, what we have is we have two pairs of right angles. Okay, and so what I'm going to do are right triangles. So this is a right triangle. Let me label that. Let me kind of highlight that. And so I know that this is a right triangle. Okay. I also know that this one down here is a right triangle. Okay. And so let's do this. Let's try and find out. Let's call this length y here. Okay. So we'll call that y, and then we'll call this one x. Okay. It doesn't matter which one we solve for first. But let's just go ahead and do that. So let's say, I know that this length is 20, okay, and it shares the length of this big triangle. Okay, I know I can set up the equation y squared plus 20 squared is equal to 29 squared. All right, so 20 squared is just 400. So y squared plus 400 is equal to 29 squared. So 29 squared is 841. Okay, and let's go ahead and subtract 400 from both sides. All right, and we can solve for y. We get that y squared is equal to 441. And so let's take the square root of that. I don't think we're going to get anything nice. Oh, cool. If I take the square root of both sides, guess what I get? Homeboy gets that y is equal to 21 inches. Okay, and so we know the length of that. All right, and I'm going to label that up here, that this is 21 inches, all right, based off using Pythagorean theorem, okay? I have a friend. All right, the next one I want to do is over here in this triangle. I'm going to try and find this length x here. This length is 20, and my hypotenuse is 25. So I'm going to set this up and say x squared plus 20 squared is equal to 25 squared. All right, so I get x squared plus 400 is equal to 25 squared, which is going to be 625. Okay, if I subtract 400 from both sides, all right, then I'm going to get that x squared is equal to, so 625 minus 400 is 225, all right. Maybe you already know if I take the square root of this and square root of that, if I take the square root of 225, I should get 15. Okay, and so I do. All right, so x is equal to 15. Okay, and that's that length here that I'm going to label here is 15 inches. Okay, all right, let's make sure we label that here with inches as well. Now it wants us to find the length of the diagonal AC. Okay, so I know that AC, if I take x and add it to y, will give me AC. Okay, so AC, all right, has a length of, what is that, 15 plus 21, okay? And so if I take 15 plus 21, that's going to give me a length of 36. So AC is equal to 36 inches, okay? So that's the idea. Just using what you know, those properties. So you do have to think a little bit. I know I kind of rushed through these notes a little bit, but we should be good. So I hope you enjoyed this video, and we will see you soon. Thanks. Bye.